Oh, hello. Start. I will start for the recording because we are recording as well. So BitDSM is we hacked it in ETH Singapore just 2 months ago. So it's a new bridgeless way of bringing your Bitcoin to Ethereum smart contracts. So we leverage EigenLayer, and it's exactly modeled after EigenLayer pods. So what happens? Think of it like a pipe. So if you're a Bitcoin user, you use Electrum or any other wallet, you just do a one-click deployment of your bod on Ethereum. So what happens is your Bitcoin address gets mapped into the Ethereum. You open a 2x2 multisig with the eigenlayer operator. So your Bitcoin gets logged in your wallet into the multisig, and they get released into the bod. So yeah, that's better. So now, as they are released into the Ethereum in a smart contract, user still has the control of it, but it's not ERC20. It's like a smart contract. You can put conditions on it how you want to spend, like that smart contract. So as an app developer, you can get hold of that smart contract. You can lock it. So if, let's suppose, I was your user, I logged 2 Bitcoin in my wallet on the Bitcoin. 2 Bitcoin are available on BitDSM, and then your app is locking it. Let's say you are a stable coin, or you are minting an NFT backed by Bitcoin or something. Um, you have locked the bod. So you have the 2 BTC available in your app now. So the app has the capability to liquidate you as well. Like depends on your own conditions. Yes, because it's a 2x2 multisig with the operator. So liquidation is possible, but user has to read your contracts and verify everything before giving you the permission to do that, before signing up to your app, basically. So that's how BitDSM works. Any questions? Solidity, yes. This is all smart contracts.
If me, as the user of the Bitcoin wallet, I want to transfer that BTC, those satoshis, those are locked, right? So if I try to move them, I cannot do it if there's a condition on the EVM, right? Because we have the MPC wallet, right? Oh, okay, perfect. And does it work with runs or only with BTC right now? Okay, okay, perfect. Thank you.
So yeah, I'll let Usman explain how this works in a dashboard, and he will show you the app registry contract. So whatever app you're building, you can just register it through a command with BitDSM, and you will get access to lock and unlock functions of that BTC. Yeah, got it? Yeah, that's fine.
So hi. So this is our basic. I can't speak. It's on. Okay. Nice. Okay. So this is our basic dashboard that we are using for these contracts that we are having. So this is live on Holisky and Signet. So right now we are using the BTC from the Signet testnet. So as a user, you can go and deposit your BTC by creating a bot. So the first thing that you need to do is to use the OKX and link your account with our dashboard. So this is already linked, so I will use a new account, let's say this one. And if I connect it here, so this should pick up my public key. And if I go and create a bot, so what this will do is, this will create a bot that is linked to the public key that you are using to sign the transaction from your wallet. So you own the contract that will be deployed as a bot, as a user. So we don't own it. So if we go and do a create bot, so we have a list of operators that you can choose from. So this is the set of operators that are basically registered on EigenLayer and staked there. So you do a multi-sig with these operators on the BTC network, which will become reflected as a value on the bot contract that we are deploying here. So you can select anyone. Let's say I select theta. So this will create a transaction that will be sent to our contracts. And this will also create a multi-sig address on the Bitcoin network, where you can deposit your BTC, which will be reflected into our bot. So Signet is slow, so. Okay, so your pod has been created. So here you can see this is undelegated, and this is the address of the pod that is now deployed on the Holisky network. So as a next step, you can go and basically fund your pod. So you can select the operator with which we wanted to fund. Let's say I wanted to deposit 0.001. Okay, fine. So this is now taking confirmation from me. That will create a BTC transaction. If I confirm it, and so if you confirm this, so this is basically creating a BTC transaction that is sending your funds to the multisig that you created when you created the bot, as well as registering the bot to our contracts so that we can verify the request. It's taking a lot of time. Okay, so this has basically created a transaction on the Bitcoin network, but as you know, Bitcoin is slow, so it will take some time. So what I can show you is I have already a bot that I have deployed that is already funded. So I can show you how can I delegate it to the applications, which is more useful for you, I think. So I have an account here, let's say this one. So as you can see, it has already 0.001 BTC staked. So this is already funded and it is delegated to. So let's undelegate it first. Okay, confirm. I can't do anything. It's slow. It's a test net. Yeah. This is. Okay, so yeah, that's done. So we have a pod that is deployed and funded. So we can just go and delegate it to the applications. So this shows you a list of applications which are now registered with our BitDSM contracts already. So these are some sample applications that we have registered. So you can select any one of them which you want delegate to. So let's delegate. And what this will do, why is there an error delegating? Oh, let's try again. Sometimes it just does the problem. I have to see. The delegation is false. Okay, maybe I need to refresh. Yeah, let's go to the smart contract. So basically, it's just a call to the contracts, and the mapping inside our BitDSM contracts get updated, and we assign the pod to a specific app, which is basically being funded here. So this is just that. This is just a contract call, but I can try it once again. Sometimes the contract just gets stuck somewhere. Let's see if I can call it. No. It was working. It undelegated, but now I don't know. So anyway, so we can go to the contracts, I suppose. So these are our basic contracts that we have deployed on Holiski. We have the Bitcoin pod with the pod that we saw, a pod manager, which actually manages the deployment and the assignment of the pods to different addresses and maintains the storage information. Then we have the BitDSM registry and the service manager. This is eigenlayer related, so that's how we get the operators registered with us. And the operators are also responsible for verifying the transactions on the Bitcoin network. So the verification is dependent on the operator, and the operator is staked in the eigenlayer. So if there is any malicious transaction or the operator does anything fishy, we can stake him on the eigenlayer. And so the most important thing is basically the app registry, where we register the apps. So any app developer can come and register with us and have access to these bots that are being deployed by users and funded with BTC. So the main function that we require is basically register app. So you just have to provide the address of the app and a signature on a digest that you can calculate using this calculate app registration digest hash. So you just first call this function and calculate a digest hash, then create a signature on it, and you just pass that signature and the digest hash to this register app, and this should be enough to register you with our app registry. Once you have registered with our app registry, then you can update the information of your application using this update metadata URI. So this helps us pick up the information related to your contract, or to your application, like name, website, description, if you want to put something. And this helps us put that information on our dashboard, the way I shown you earlier, where I showed you the list of the apps. So if you can, so you register through this one. And what else? So if you want, you can also deregister back. So once you deregister, you also have to release all the pods out of it. So we have created a very basic example to show you the locking and the unlocking, which is actually available on our BitDSM GitHub as a BitDSM examples folder. So if we can go back there, that's a script. So we have provided these reference scripts for registration and deploying on app, so that you can look at the code. And so if you want, I can go through it. So basically, this is a simple time lock app, which is provided here in the examples. So it does, so what it does is basically locks an app for a certain period of time, and then unlocks it when the time has expired in terms of number of blocks. And what it uses is the pod manager to lock the app. So basically, you can import the pod manager using these interfaces that we have provided already. And you can call this lock pod and unlock pod to lock or unlock the application with the pod. Right. So the registration and the deployment. So this is a simple application that we had for lock. So this was a deployment script which just deploys the main contract. And once you have deployed it, you just copy the address of the application and use this register app script to register it to our app registry. So you can see here, the process is the same. I've just called the app hash digest calculation. Once I have it, then I create a signature on it and just checking that the signature is valid. So another important point is you have to provide this valid signature function inside your app, because we are implementing the ERC 1271 contract base signature verification. So your own app determines what kind of signature you want to verify. Is it a single party signature? Do you want to implement a multi-sig, or do you want to have a contract given the authority over this application? So it's up to you. So the only thing is you just have to override this as valid signature function in your own application and provide the appropriate logic there, and it should be able to register it independently. And you just call the register app function, and it should be enough to register it. Apart from that, we also have a CDP example which shows a collateralized desk position. So it's a very basic example which locks the pod, which it gets from the app registry in this case, and then mints a ERC20 stablecoin given the liquidation and the collateralization that is provided by the user. But it's just two simple examples provided to teach you how to use the app registry and how to register the app and what can be done. So that's pretty much it from us. Is there any question? Sorry, I can't hear you. No, the Ethereum gas is paid on Ethereum. So there are two different kind of gases that are going down there. So there are two different kind of transactions. When you fund your pod, that funding transaction happens on the Bitcoin, so the gas is paid on Bitcoin. Yeah, right. The rest of the contract interactions all happen on the Ethereum, so you pay the Ethereum gas fee.
Okay, got it. Perfect, thanks.
That's the whole point of the application, that you move the Bitcoin from Bitcoin to Ethereum and make the value representation in a contract on Ethereum. Once it's there, then it's all Ethereum ecosystem. It's all Etherland.
Okay, perfect. Thanks.
Is there any other question?
Yeah, so I think that's it. We are offering bounties for the hackathon. So if you just register the app, whatever you end up building, you will be eligible for the judging for the bounties. Yeah, so, yeah. Thank you.